This lesson is for, I'm sorry, this video is for lesson 3.2, ratios and proportions. A lot of this stuff you would have learned like for the first time in sixth grade is when you really hit ratios and proportions pretty hard. So a lot of this should be reviewed, but some of it'll be a little different just because we're getting an algebraic twist to it, especially in the problems later on in the assignment. But just as a quick reminder, so a ratio is just a comparison of two quantities, usually through division. A rate is just sort of an extension of those quantities. So let's just say that um, a basketball coach wants to order, so they have 2 basketballs for every 5 players. That would be a rate. So 2 basketballs for every 5 players at practice, and more realistic is probably like 1-to-1. But if they want to have that much, so then to extend that, well, then for 10 players, if we just double the number of players, we would double the number of basketballs needed. So that would be an example of a rate where we're just repeating that original ratio according to whatever the situation is. A unit rate would then be based on one of something, typically one of the denominator. So if I was saying, well, there's 2 basketballs for every 5 players, a unit rate would be to, well, how many would it be for 1 player? Which in this case might seem a little odd. So just a quick reminder, to ever do unit rates, you just take your original ratio and you want to get your denominator to 1. So in this case, I would divide by 5 to get down to 1 player. And whatever I would do to my denominator, I do the same thing to my numerator. Divide both by 5. 2 divided by 5 is going to give me 2/5 or 0.4. So that would really be like having 0.4 basketballs per player. In this case, it doesn't make a lot of sense because 4/10 of a basketball doesn't work very well. But if we were talking about money or something like that, in those cases, decimals do work. So again, ratio is just a comparison of two quantities. A rate is often just an extension or repetition of that ratio. A unit rate is a ratio in which your denominator is based on 1. So if you hear unit rate, that's what you're looking for. And then proportions are just a comparison of equal ratios. And that's probably the thing that we'll actually kind of spend the most time on, or that'll be probably the most algebraic, is finding proportions using algebraic expressions. All right, so clear this off. And so your assignment, I believe, was 3, 7, 11, 19, 23, something like that. So I'm not going to do necessarily those problems. I'll do ones like it. So for number 1, they ask for the ratio of A's to B's. Well, I'm going to do number 2, which is the ratio of A's to C's. And you need to read up above for that one. So it says 8 students received an A, 10 received a B, 6 received a C. There were no D's or F's. So they want the ratio, but notice they say in lowest terms. So it means they want you to simplify it. So let's see, there were 8 who got A's. So I might originally just label it as 8 A's. And I do like to label ratios. I know sometimes even the book, they don't necessarily do that, but just to kind of keep track of what's what. So there are 8 A's, 2, and I'm doing number 2, but number 1, you do A's to B's, but I'm doing problem number 2, just as an example. That's a 2, by the way, messy one. And to C's, there were 6 received C's. So I might say, all right, there are 8 A's to 6 C's, but I'm not done because they want me to simplify, and they also wanted me to express the ratio using words rather than a fraction. So 8 to 6, I could simplify that down to 4 and 3. Another important thing with ratios is you want to list them in the order they're asked. So if they ask for A's first, we list A's first. If they ask for C's first, we list C's first. So I'm going to do 4, and really it's 4 A's, but the way they're asking for it, they just want the number. So it's 4, 2, 3. And that's the word 2, not the number 2. So that is the ratio of A's to C's in simplified word form. So 4 to 3. So your answer for number 1 will be something similar. All right, so you're asked to do number 7. So as an example, I'm going to do number 6. Again, if you already know how to do these, you don't necessarily need to watch every example, but if you're not sure, I recommend doing it. So I'm going to write my ratio. So number 6, they say that it's $27.50 for 11 gallons of gas. So I'm going to write that as a ratio, and I'm going to write it in the order it was given. They told me the money first, so that's what I'm going to list first. $27.50 to 11 gallons. And I like to write it as a fraction. So from here, they want to be the directions say find a unit rate. We just talked about that a little bit ago. A unit rate is when you get that denominator, that lower value, down to 1. That's where the term unit comes from. It just means one of something. So instead of 11 gallons, I want to know what the cost of 1 gallon would be, which is going to be more useful to me than knowing what 11 gallons is. So to get from 11 gallons to 1, I'm dividing by 11. If I do it to the denominator, I do that to the numerator. So I'm really doing 2750 divided by 11. Now I've been letting you use calculators on some of these because the main point isn't whether or not you can divide by 11, it's do you know what a unit rate is and how to do that. So in this case, you would divide, and it's going to come out being, there'd be 5 left over, bring another 5 down. So it's going to end up being $2.50 per gallon. So that is the unit rate, $2.50 per gallon. So that's what we're looking for number 6. Number 7 will have a similar answer. You just want to get it down to unit rate. Number 11 is a little bit trickier because you need to do a conversion in that one, but I think it's not a real tricky conversion. So I will do number 10. So they say that my original ratio is $4 per pound or per 1 pound. If they don't give us a number, we're just going to assume it's 1. So $4 per pound. It's a little tricky writing a 1 next to an L because, at least for me, they end up looking a lot alike. But they want that to be converted into cents per ounce. So there's really 2 conversions. I've got dollars, but I want it to be cents. Well, I know in $4, there's 400 cents. So I'm going to change my $4 to 400 cents. And then they want, I know in 1 pound, there are 16 ounces. So I have an equivalent rate right here. However, they didn't come right out and say, write it as a unit rate, but I think that's implied. So I'm going to get this down to unit rate. So I don't want to know what it is for 16 ounces. I want to know what it is per ounce or for 1 ounce. And if you go to grocery stores, sometimes in the labels, they'll even have they'll figure it out for you, the cost per ounce or sometimes cost per dollar. So that's kind of useful sometimes just to know which is your better deal when you're buying things. So to get from 16 ounces to 1 ounce, I'm dividing by 16. If I do it to the denominator, I do that to the numerator. 400 divided by 16. I could write that off to the side, but in this case, I happen to know that it's going to be 25 because 16 quarters makes $4 or 400 cents. So in this case, it ends up being 25 cents per ounce. That's how that works out. So that was number 10. Number 11 will work similarly. All right, so next, I think I asked you to do, was it number 17? I will have to double check that because I don't actually have it written down. Why don't we skip ahead though, because I'm going to do number 20. So this is actually probably the newest stuff. This is like stuff that you maybe haven't seen or done before in previous years. So we're adding more of an algebraic twist. This is number 20, and this is going to be very similar to the rest of the ones in this section, number 19 through 26 and so on. And what you're going to do on number 20 is you got 3x over 25 is equal to 63 over 175. So something that's true, so this is a proportion. We're solving proportions, and something that's true of the proportions is it's a comparison of equivalent fractions. So for example, if I took 2/3 is equal to 4/6, hopefully we all agree that 2/3 is equal to 4/6, because if I just doubled each of these values, I get the same numbers. Or if I was shading in a pie, 2/3. So if I have this one and this one, well, if I cut it into more pieces, I haven't changed the value. I just have more pieces. So it's just a different name. 4/6 is equal to 2/3. That's the point. So something that's true of things that are proportional is that if you were to multiply cross products, they will be, or multiply across, you'll get equal values. So in this case, 2 times 6 is 12. 3 times 4 is 12. And that's going to be true whenever you're comparing things that are proportional. So that's going to be still apply here as well. The numbers are uglier, but still work. So if I do cross products, 3x times 175 should equal 25 times 63. So 3 times 175, that should be 300 plus 225 should be 525x. I'm doing this in my head, so if I make a mistake, maybe you can catch it for me. And then I'm also going to multiply across this way. So one trick for multiplying by 25s, 25 is a fourth of 100. So I could actually, if I'm doing this mentally, I could do 63 times 100, which will give me 6,300. And since 25 is a fourth of 100, I could take a fourth of this. So I know a fourth of 6,000 is 1,500. And again, you can just use a calculator, but I'm not, so I'm trying to find another way to do it. A fourth of 300 is 75. Add those together. So that'll give me 1,575. And now from this point, now it's just balancing equations. So I'm going to divide both sides by 525. Getting kind of messy there. So here it's going to factor. I'm just left with x. Sorry about all this stuff down here. And just looking at that, I think 525 is going to go into there 3 times. So in the end, x just ends up being 3. And there are other ways you could have found that as well. Like you could look at this and say, well, 25 or 175, if I want to change that to 25, well, that goes in there 7 times. You could just divide this by 7. Then you could also do this divided by 7. 63 divided by 7 is 9. Well, 3 times what makes 9? 3 times 3. So there's other ways you can do it, but this cross products way is one way that will work even for kind of messy, ugly problems.